I'm Sneha from the Web3 Compass, and this is day 29 of 30 days building with Solidity. I know, right? Second last. I can't believe how quickly the month passed and how far we have all come. Like everyone in the community, so many of you have been coding every day, waiting for our videos, giving us shout outs, writing blogs, tweets, sharing with the community, learning every day. And we can't be more proud. All of us have gotten into this habit, coding every day, waiting for videos, creating videos, although it was a tad bit tiring. Me and Setu have cried so many times for things not working out, but then we are absolutely proud of, having this consistency achieved. And we really hope that the next campaign we come up with is a level more fun and better and a good learning experience for you guys. But yeah, 2 more days to go. Right? So for everyone, again, if you are new and you don't know what I am talking about or why am I so happy, you can go to our day 1 video. That is where we talk about the entire campaign in detail, or you can head over to web3compass.xyz. It's not just the challenge that we have, but we have a learn section, we have a play section, we have an explore section. So too many things for you to look at. And we also have a YouTube channel at the name @ the Web3 Compass. This is the amount of videos we've made. Yeah, so proud. Started 3 weeks ago. So, oops. Yeah, sorry for that. Okay, so let me go back. Yeah. This is day 29, and today we're going to talk about stable coins. Okay, so we've already looked into building ERC20 tokens, building a digital currency that maintains a stable value is what a stablecoin.sol is going to be all about. You will learn how to keep the price steady using peg mechanism, demonstrating stablecoin mechanics, and it's more like a digital dollar showing how to create stablecoins. Okay, so we have created our own ERC20 tokens, locked up treasure, setting up access controls, guarding against re-entrancy attacks, and even handling money safely. You didn't just read about it, but you actually built with us. So now you should be ready for the next step. Now, before we get into this, why do stable coins matter so much? Imagine that you're trying to live your daily life, okay? But the value of money in your wallet just keeps jumping 30% up or down every few hours. Like yesterday, the cup of coffee cost $3. Today it's $6. Tomorrow maybe it's $1.50. That's how wild cryptocurrencies have been, like Bitcoin and Ethereum can be. Fun for investors, maybe. Practical for payments, absolutely not. That's where stablecoins come in. They are like an anchor in the stormy seas of crypto. Yeah, that's ChatGPT. The subtle lines that I don't really like to omit. Now, they are designed to stay stable, typically pegged 1:1 to a major currency like US dollar. And they are the silent heroes behind trading, saving, borrowing, lending, everyday transactions in Web3. In fact, if you look around DeFi today, almost every DApp, every NFT marketplace, every lending pool, every DEX, they all rely heavily on stable coins behind the scenes. So if there are no stable coins, the entire DeFi world would feel like trying to shop in a market where prices change every 5 seconds. Okay. But aren't like stable coins supposed to be like super complicated? Yes. Absolutely. Real world stable coins like USDC, DAI, USDT are incredibly complex. They involve collateralized reserves, on-chain and off-chain oracles, dynamic supply adjustments, governance boards, full audits and legal compliance and all of that. And this is just us scratching the surface. But here's the thing. You don't need to dive into that complexity to understand how the core idea works. Okay. And what we're going to be building today is a very beginner friendly version, carefully designed to strip away all the overwhelming complexity of stable coins. And we will zoom in what actually matters. How do you mint stablecoins? How do you redeem them? How do you back them with real collateral? How do you calculate safe margins and protect the system? And this is more of like a training ground for you. Okay. Now, before you or we dive into the code, here's like let's do like a quick discussion of what's happening behind the scenes. Okay. So users will deposit a collateral token like ETH, USDC, or any ERC20 token that we decide. And based on the latest price fetched from the price feed, the contract calculates how much stablecoin they can mint. To keep the system safe, we make sure that users always deposit more collateral than the value of stablecoins they are getting. Think of like a 150, like thanks to the 150% collateralization ratio. Later, when someone wants their collateral back, they can redeem their stablecoins by running them. The contract also would include basic owner controls like updating the price feed or collateralization settings and protect against common vulnerability attacks like reentrancy. That is what we've been talking about all along. And again, very beginner friendly version, core mechanics like minting, redeeming, collateral management, etc. And yeah, let's get started. So we will create a file, simple stable coin. So this is going to be our main contract, but we will also have another ERC20 contract, again using Open Zeppelin. That's like 5-6 lines. You probably would already have it saved either as token A or governance token, which we also did yesterday for our DAO contract. So no need to worry around that. And that would act as a collateral basically. Okay. So let's just copy this first. Close this. Let's also close this. Come to simple stable coin. Now, what we're doing is we're doing a few imports here, actually quite a lot. As of now, the maximum that we've done is like 3, I guess. Okay. So I've just copied everything. There's ERC20.sol. We have already talked about ownable.sol again, which talks about ownership access. And like a basic template of it, reentrancy guard.sol, great, safe ERC20.sol, access control, yes, IRC20 metadata, yes, we have talked about it before, and aggregator v3 interface.sol. I think this was a part of decentralized lottery. So I know everyone who has been following us for the past 30 days, you already know why all of these matter and what it means, but I will still explain. Okay. So simple stable coin is ERC20 ownable reentrancy guard access control. Okay, great. So we have imported like half the things here already. Okay. Now let's just quickly go through the imports, what we're doing, right? So the ERC21, come on. We've been like talking about it forever. ERC20 from Open Zeppelin, which gives us all the standard token functionality, minting, transferring, maintaining balances without writing it from scratch. Then comes Ownable, which is like a simple ownership system. Sensitive settings like updating collateral ratio should only be changed by the contract owner. And this module basically handles that. Reentrancy guard is the third one. Again, protect important functions like mint, redeem. Wherever we're dealing with money, we need to save it from these attacks called reentrancy, where a malicious contract tries to repeatedly call a function before the first call finishes. You should watch the previous videos. Okay, safe ERC20. Now, this is a safety net for dealing with other ERC20 tokens. Sometimes token contracts behave badly, like failing transfers without errors, and safe in ERC20 ensures all token operations either complete successfully or fail cleanly. Okay. Then we import access control, which allows the contract to define custom roles. In this stablecoin, we have a special price feed manager role. So specific accounts can update the price feed without having total admin control. IRC20 metadata is there to help us fetch extra information about the collateral token, like how many decimal it uses. Different tokens have different decimal setups, and it's important our math accounts for that. I think we've talked about it in lending pool. Yeah, that is where we talked about it. So come on, go watch other videos. And finally, and the most importantly, we have aggregator v3 interface.sol from Chainlink. This is what lets our stablecoin see the real world price of the collateral token. Instead of guessing or relying on manual updates, the contract can automatically fetch trusted, decentralized price data, keeping the system accurate, up to date, and secure against any kind of manipulation that can happen. And we've done the contract declaration. We've said that, hey, we're creating a simple stable coin which will inherit everything from ERC20, which will, bring us all basic token behaviors. And it will be ownable too, because we need to add a simple ownership model here. We will protect the critical functions through reentrancy guards, and access control will allow us to define some custom rules. That's what we're doing. Now we'll talk about state variables. Okay. So that's how we start, right? Past 28 days, that's what we've been doing. We do the imports if necessary. We do all the declaration. We write the contract, we create the contract, and then we just go to state variables. I don't know what I was trying to say here, but you know the process: license, version, imports, and then writing and getting started with contract. Okay. So, yeah, I know AI is suggesting using safe ERC20 for IRC20. Yes, that's what we'll do. Again, to use safe transfer and approve. And this line basically activates the safe ERC20 for all IRC20 tokens we interact with. So this will be IRC20. Oh my God, I don't know what are these. Can we remove this? Yep, correct. Okay. Now what we do is we write bytes 32 public constant. So we're declaring a constant, and we say price feed manager role equals to what? Take it 256, and then we say basically going to hash it. Okay. Then what else? We would need one collateral token, right? That has to be immutable. So we make it immutable. We say, okay, IRC20 public immutable, and we say collateral token. Great. Fine. Now what we do, we are saying we need collateral decimals as well. Like how many decimals do our the collateral token has, right? So we say, wow, that's a lot. Like that's a big name. Come on. We say collateral decimals. That's it. We don't need token stuff. Great. Now what else? So we're saying we are using the v3 interface. So we're saying public and price feed, and also a collateralization ratio, which is again fixed here. Collateralization ratio. Okay, so it's expressed as a percentage, not as basis points. Oh, ratio. Public. The errors that I do. Okay, yeah. Okay, so now what are we doing here again? First line, this line activates safe ERC20. It will automatically wrap methods like transfer from, transfer with safety checks. Then we're saying, we're basically creating a special role called price feed manager role, which controls who can update the price feed. You will notice it that it is stored as bytes 32 constant. Now here's why, because bytes 32 is used because the role identifiers in access control are always expected to be exactly 32 bytes. It's like a standardized format that makes role checking really fast and efficient inside the EVM. So, and the constant means that this value never changes once it's deployed. It's like hard coded into the contract forever, making it cheaper on gas and safer. And we're generating it using K256 so that the role has a unique, a cryptographically strong identifier instead of just using a plain string. Okay. Now with IRC20, we're basically storing the address of the ERC20 token. Users must deposit as a collateral, and that is the ERC20 contract that I was talking about, which we'll look into during deployment. There's nothing to talk about it. We've already discussed it like multiple times. Okay. Then we're saying every collateral token can have different number of decimals, and we're storing it in collateral decimals. Great. And now the other variable, which is the aggregator v3 interface price feed, this variable would point to Chainlink price feed contract. So we will use this to fetch real-time price of our collateral token whenever someone mints or redeems stable coins. And then there's a collateralization ratio section, right? Very simple, self-explainable. Now let's write some events. Okay, so we're saying event minted, saying address indexed user uint 256 amount uint 256 collateral deposited. Great. Now if it's minted, it's also could be redeemed, right? So we say redeemed, and we say user amount and what? Collateral returned. Okay, great. Now what? Emit price feed updated, since we're talking with the real contracts here. And we will say address of the new price feed. Great. Oh, not emit, event. Okay. And then what else? Okay. Maybe collateralization ratio updated. Updated. Okay. Say uint 256 new ratio. Great. Fine. So these events are again self-explainable. Event minted, who minted, how many stable coins they received, how much collateral they deposited. Indexed is again easy to search, filter and search for all minting actions by a specific user's address in the blockchain. And then there's redeemed, who redeemed, how much did they redeem, and how much collateral they got back. Right? Price feed updated. Again, this event signals that price feed address has been updated. It records the new feed's address so that everything remains fully transparent. Users can trust any changes to any critical data sources that we are referring to. And collateralization ratio updated. Again, event announces whether or whenever the collateralization ratio has been changed. User and apps monitoring the system can immediately require if the safety buffer is raised or lowered, right? Now, we're going to talk about something extremely new here, which we've not discussed as of now, which is custom errors. So when something goes wrong inside a smart contract, like an invalid input or a failed check, we want the transaction to fail gracefully, and explain why. Because in older Solidity code, this was usually done with required statements and error strings. That's what we've been doing for so long. For everything, we're writing a require condition, right? But that approach is expensive on gas. Custom errors are newer, cleaner way to handle failures. They're cheaper, easier to read, and make debugging extremely simple for users. So we'll declare some custom errors. So we say error invalid collateral token address. Now come on, You understand this one, right? Like if you've added some other collateral token address, it either does not exist or it's not pegged to your stablecoin. This is the error that we're going to talk about. Error. Invalid price feed address. Maybe it's not the right data source, right? Just figure out from the name what it could be, right? Error. Mint amount is 0. Now, if we would be writing a required condition, we would basically be checking the message.value or the amount that we are passing and check, hey, is it greater than 0? Yes, great. Otherwise, return. Yeah, like the mint amount has to be greater than 0, something like that. But here we're just declaring it as like custom error. Error, insufficient stable coin balance. Okay. And then the last one could be error, collateralization ratio. Great. Yeah. Wow. New thing that we're learning, right? So now again, everything is understandable. Come on, there's nothing to explain here. Someone tries to give a invalid collateral token address like 0 address or maybe 0 address or without a real token actually backing the system, the whole stablecoin wouldn't work. So we stop it right at the start. Invalid price feed address. Again, this error triggers if the provided price feed address is invalid because we're depending heavily on the live price data. Connecting to a bad feed would make the system unsafe. Mint 0 stablecoin. We throw this error because it doesn't make sense. Insufficient stablecoin balance. Like, if the user is trying to redeem more stable coins than they actually have in their balance, that is when you throw this error. And then if someone tries to set the collateralization ratio below 100%, this error is thrown because allowing a ratio under 100% would mean that stable coins aren't fully backed, which is like a huge risk. So we enforce like a strict minimum, and generally it's 150%. Okay. Now we'll do our favorite thing, which is writing the construct. Say construct. Great. Now what do we have here? We will obviously have the address of the collateral token. Then we have the address of the initial owner. Okay, and then we have the contract address of price feed. Very simple, right? Okay. Then what we're saying, we were importing ERC20 as well. ERC20. Okay, great. And we say simple USD stablecoin. This is like the name. So we generally provide the name and the symbol and we say SUSD. Great, fine. And ownable, because we're talking about ownership, and since you're importing it from the Open Zeppelin framework, you have to give an argument here, which is again the initial owner. Now we'll check a few conditions. If collateral token is equals to address 0, what would you generally do if we were using required, right? You would give something to print, but here we say revert, invalid. Come on. Great. This is how custom errors work. So just like for every event, there's going to be an emit. For every error, there's going to be a reward if that situation is reached. Then we say if price feed is equals to address 0. Great. Revert, invalid price feed address. Fine. Okay. Now what we do is we say collateral token, okay, is equals to IRC20. Now we have done this so many times that I don't think I need to explain this. I mean, I will anyway do. Collateral decimals is equals to IRC20 metadata, and we say collateral token dot decimals. That is how we get the decimal value here. And we say price feed, right, is equals to aggregator v3 interface and what underscore price feed. Yep. Okay. So what did we just do here? Everything. Like the initial conditions are self-explainable. Why you've given certain parameters, how we're looking at custom errors now using revert, just checking the condition, nothing else. Okay. Now once we have, checked all of these conditions, we have to save the address of the collateral token so that the contract knows what tokens users will deposit. And that is what we're doing here with this line. Okay. Then different tokens have different decimal formats. We fetch and store the collateral's token decimal right now, so we can handle all math correctly later. That is what happens with the second line, which is collateral decimals, IRC20 metadata, collateral token dot decimals, and we connect our contract to the Chainlink price feed, giving it the ability to fetch live price data on demand. Now, it's time that we grant two important roles. So we see grant role. What is that role? One is default admin role. And who is that person? Initial owner. Initial owner. Great. And what is the other? Yeah, you're right. Price feed manager role. So it's price feed manager role. And who is it? It's the initial owner. Who else? Great. So this is how the constructor is gonna look like. Okay, now what we'll do is we'll get started with the functions. And the first thing that we write is getting the live price from Chainlink. Now, this function is more like a helper function that we use throughout the contract in both minting and redeeming logics, as well as in like view functions, right? So instead of getting or repeating the same price fetching logic everywhere, we would wrap it neatly in a function maybe called get current price, so it's reusable and easy to maintain. Let's just get started. We say function get current price. Great. We say public view returns again. What will it return? 256. Yep, UN 256. And then we've talked about this also, that if you have got like a tuple and you know that there are going to be 5 parameters altogether, and all you need is like one, instead of getting all of those values, you just pick the one that you need. Okay. So yeah, you can just go to our previous videos. I've forgotten which video I have talked about it, but we've talked about it in detail. And then we say required price is greater than 0. Otherwise, we say invalid price feed response. And then we say return. Now, because we have gotten the value as int 256, this is how it's there in the price feed. So then we convert it to uint 256 price. Great, right? That's how you do it. What else? Once we have written the get current price, because we we, 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 we need the live prices here, which means a lot in the stable coin. it's time that we start writing the mint function, because that is where users are going to deposit collateral into the contract and receive freshly minted stablecoins in return. This is the entry point for anyone who wants to create a new SUSD tokens based on the value of their deposited assets. So, function mint uint 256 amount, again, missed something. And then we say, hey, this is supposed to be external. Let's make it non-reentrant. Okay, great. If amount equals to 0, revert what? Mint amount is 0. How easy to write this, right? Now, we say uint 256, that's a collateral price we're talking about. So we use the get current price, which we just wrote. So we call that function. Okay. Now what happens? Uint at 256 a required collateral value. Collateral value USD, okay, is equals to what? The amount of stablecoins that we want to mint into 10 to the power decimals. Okay, we're taking 18 decimals assumed for SUSD. And then we say uint 256 required collateral. So we say whatever is the required, required collateral value in USD, you multiply it with collateralization ratio divided by 100 into whatever is the collateral price. Okay, basic logic. Now what we would do is we would also get an adjusted required collateral. So we say adjusted required collateral. So we say whatever is the required collateral, right, into 10 to the power collateral decimals, and then we divide this by 10 asterisk price feed dot decimals. Wow, what did we just do here? Okay, so the first two lines are clear, right? There's nothing much happening. Then uint 256, we are declaring a variable called collateral price, and we are calling the get current price, which fetches the current live price of the collateral token using our connected chain link price feed, right? Now, in required collateral value USD, we calculate the USD value of the stable coins the user wants to mint. Now, since the SUD uses 18 decimals like ETH, we multiply it from 10 to the power 18 to handle the scaling properly. Now, there's another variable called required collateral. So now we have to calculate how much collateral value in USD terms the users need to deposit based on the collateralization ratio, like 150%. Okay, so if you want to mint $100 of SUSD at 150%, you should provide $150 worth of collateral. Okay, now there is another variable that we declare, which is adjusted required collateral. Since token and price feeds often use different numbers of decimals, 6, 18, 12, I don't know, we adjust the numbers here to make sure that the calculation is precision correct for both the collateral token and the price feed. Okay, now what we have to do is that once we have, this is decimals, yeah, Now, once we have done this, it's time we safely transfer. So we say collateral token dot safe transfer from. Again, we have talked about this function in so much detail in ERC20. And we say message.sender, address this, which is again the address of the contract. And then we say adjusted required collateral. Okay. So we use the safe transfer from, make sure that the operation either succeeds fully or fails very cleanly, no silent errors are there, and then we would just mint. So we mint message.sender and the amount that we needed, the amount of stablecoins, right? Great. And then what we do, we just emit minted and we say, okay, message.sender amount and not required, it would be adjusted required collateral. Okay. Yeah, because we've done all the calculations here as per the price feed and that. So finally, we fire the minted event recording who minted, how much they minted, and how much collateral they deposit, giving the dApps and the users full visibility into what just happened. Okay, now it's time that we talk about redeeming stable coins. If minting is how users create SUSD by depositing collateral, redeeming is how they burn their SUSD and get their collateral back. The next function that we're going to write is going to do just the opposite of mint. It ensures that the user has enough stable coins, calculate how much collateral they should get back based on the latest price and safely return it to them. So let's just see what we need to change. Maybe just try to copy all of it and then we'll see what happens. Okay, maybe we don't need this. Let's just do it and see how burn is going to be different. Okay. So the first thing, we have to change the name here. Let's say redeem. Okay. So we need an amount that also has to be non-reentrant. It's fine. Amount equals to 0. Great. And then we revert mint amount is 0. Okay. Now what? So we would have to check one more thing, is the user having enough stable coins as it is trying to redeem, right? So we say balance of message.sender is less than amount. Okay, great. What would you do? If not, revert insufficient. Why am I not getting this? Insufficient stable coin balance. Yep, great. Fine. So we have checked another condition. Now we need the collateral price as usual. So we use get current price. Now we need stable coin value in USD. So we will just say, let's make this stable coin value USD. So there's amount into 10 to the power decimals. Now I'll copy this. Maybe instead of every required collateral, we just have to replace stablecoin. Okay. But here, instead of required collateral, we need how much collateral we have to return. Right? So we say, okay, let's make this collateral to a return. And then here we're going to take the stablecoin value USD into not the collateralization ratio, but it's going to be the opposite. So we say into 100 divided by collateralization, such a big term, ratio into collateral price. Great. Now adjusted collateral to return. Okay. We say what? We copy this because this is what we're going to use here. So we say collateral to return. Okay. Then what? Into 10 to the power of collateral decimals. Great. Divided by 10 into price fee dot decimals. Great. Just a minor change, right? Now, before this minting, here we would burn the amount, right? So we say burn. That's how we're going to get, right? So we say burn message.sender amount, and then we will do this collateral token dot save transfer from what message.sender, and instead of this entire thing we just need this variable. That's what we did for mint as well. So we say adjusted collateral to return, and then instead of minted we say redeemed message.sender amount, and again what adjusted collateral to return. Okay, and this will not be safe transfer from. This has to be a safe transfer. What did we just do? Did we just make minor changes in the previous one with just variable names and did something up and down? So, okay, let me explain. We check the amount because we have to block zero value redemptions right away. Redeeming nothing is waste of gas. Again, we check that the user actually owns enough SUSD to redeem. If they try to burn more than they hold, the transaction is reverted. Now, we fetch the latest real world price of the collateral token from Chainlink. This ensures that the amount of collateral the user receives is based on up-to-date data, trusted market data, right? Now, we calculate the USD value of SUSD tokens being redeemed, properly scaled using 18 decimal places. That's what we're doing here. Okay. Then we're saying collateral to return. When they figure out how much collateral value they should be returned based on the collateralization ratio and the current market price. So if you're redeeming $100 and the ratio is 150%, you should get back around $66.66 worth of collateral, right? So that's what we do, calculate that. Then there's adjusted collateral to return. So here we adjust for any differences between the number of decimals used by the collateral token and the price feed. So the amount returned is precise and accurate. And now we have to burn the stable coins being redeemed, permanently removing them from circulation. And then once the SUSD is burned, the calculated amount of collateral is safely sent back to the user's wallet. And then we emit a redeemed event. Ta-da! That's it. That's all that we have to do. So now it's time we write another function. So we're going to write a function to set collateralization ratio. Okay, so the function will allow the owner to adjust the system safety buffer, the percentage of over collateralization required when minting new stable coins. Okay, tuning this ratio can help respond to the changing market conditions like high volatility, but it's tightly controlled to avoid any kind of risky settings. So we say function set collateralization ratio. Great. Then we say UN 256 new ratio. We make this, come on, external, and then we say only. Great. So we say if new ratio is less than 100. Come on, we have written a custom error for this. You should know it. Sorry. Or a minus. So if new ratio is less than 100, revert collateralization ratio to low. Okay, great. Then we take the collateralization. Keep like so much focus to write this correct. Why am I adding an N at the end of ratio? And then we say is new ratio, and then we have to emit collateral ratio updated. That's our event. Great. It's new ratio. Ta-da! Great. We've set it down. No rocket science here. We enforce a strict lower bound. The ratio can never go below 100%. Otherwise, there's a custom error. So that ensures that every stable coin is always backed by at least its full value in collateral, if not 150%. If the new ratio is valid, we store it and we just emit an event so that the change is visible on chain. Great. Now we'll write some cute helper functions like, oh no, we have to update the price feed or set price feed as well. So we will write a function for that. We say function set price feed. And these are very important because these are the backbone of any collateral backed stable coins. If the data source breaks or needs an upgrade, or we need a way to safely update it without redeploying the entire contract. So we say set price feed contract address new price feed. Okay, then we say external only role. We're not doing only owner here. Only role, who can do it? It's the price feed manager role. That's how we write it, just like we did for modifiers. Now, if if new price feed is an address 0, we have a custom error for this. Oh my god, I'm loving writing the custom errors. Revert invalid price feed address. Great. And then we say price feed is equals to what? Aggregator v3 interface, and then put new price feed address. That's how we update it. And then we also emit an event so that everybody knows it. Price feed updated with what? New price feed. Wow. There's literally no logic implementation. Just checking a few conditions and bam, we're done. Okay, great. Now what do we need? We've written set collateralization ratio, we've written set price feed contract, we've written mint, we've written redeem. What now? Okay, so probably you would want to preview the required collateral. Like before a user calls mint, it's helpful to know exactly how much collateral they would need to deposit. So we should write a function that makes that easy. It lets front ends and users preview the required amount based on the live price feed and the current ratio without actually sending a transaction, right? So let's write it. Okay. Function get required collateral for mint. Good. UNT 256. And we say public view returns and what? UNT 256. Three times something's missing. Okay, great. So we say if amount equals to 0. Come on, you know what to do. Return 0. Small a. Sorry. Okay. Now again, this entire thing could be just copied from here. Okay, because that's how we're doing the calculation. No need to write it. You just want to view it before you do the transaction. So we get the collateral price, we get the required collateral value in USD, we get required collateral, and then we get adjusted required collateral. Everything's same. And what we have to do is just, return adjusted required collateral. That's it. That's how you're gonna view it. No logics here. Again, view function makes it very easy, meaning it down doesn't modify any state, only reads from the contract. So anyone can call it and check how much collateral they would need to mint a given amount of USD. SUSD. Okay, great. Now, maybe I would want to write a similar function for redemption as well, like counterpart of get required collateral for mint. It helps users check how much collateral they will receive if they redeem a certain amount of SUSD. Again, pure read-only function that's super useful for front ends and wallets to give users clarity before they take any action, right? Come on, let's do it. Let's just keep writing. So we say function get collateral for redeem. UNT 256 amount. Okay. Public view returns. Returns what? 56. Okay. Now this is going to be the same thing here. Right? Yep. Okay. So we check amount is equals to greater than 0. But here we do not have to like revert anything because come on, we're just checking. This is not required. Okay. And we're saying collateral price, get current price, stablecoin value USD, collateral to return, adjusted collateral to return. And then it's time we return it. How cute. No? Is it not cute? I like it. Helper function is the best. 2. Return. Great. So now you can just get it done. Like you've implemented the logic again. So that's your code. Now it's time that you deploy it. Okay. So you have to do one thing first. There would be a token a.sol. Again, create a new file. Pick up from the old ones. We've already talked it. Okay. And we say, okay, we need these many tokens. Fine. And we have to deploy this. Okay. So we first deploy this custom ERC20 token, but we have to make sure that we set the environment to Remix VM mainnet fork. Okay. Compile. Mainnet fork. Yep. Great. So we deploy it. While this is happening, I don't know how much time will it take. I will check for ETH USD price feed chain link. There's an address. Yeah, I think we've used this before, but I'm not sure if it was testnet or mainnet. Yeah. This is the address. We have to save this. Okay. Save this. And the decimals here is 8. Must be written somewhere. Yeah. Okay. And okay, so this is deployed. Okay. Now the second step was after the deployment is done, we had to identify the Chainlink price feed address. So if you're using a mainnet fork, you can just interact with the actual deployed contracts. For example, this ETH-USD price feed that I'm talking. So we've gotten the address and the decimal is 8. Okay. Now we will just go to simple stablecoin.sol. Again, ensure that all necessary imports are there, and then you will just compile it, and it's still at mainnet fork. Now the constructor parameters. Okay. So for price feed, we've copied the address, right? This is the price feed's contract address. Great. This is going to be the collateral tokens address, which is token A, and then pre-funded account, any of it. Like, let's just take this one, right? This is the initial owner, and we deploy it. Ta-da! Oh, it's pending. Okay. So now once this deployment happens, it's time to interact with the deployed contract. So what you have to do is, once we have the contract address for stablecoin contract, we will go to my token contract and call the approve function, give the address of our deployed stablecoin contract and amount of tokens that we want to approve. Okay. That is how we're going to let it spend. Okay. So here's token A, here's approve, there's spender, so there's copy here. This is the address. So we're letting the smart stablecoins contract address, the approval to spend the value. And we want to give, suppose, 1,000 tokens. So we'll have to add like 18 decimals to it. So I've just written it somewhere. And then you do transact. Okay. Now, once given that value, you would just go to Oh wow. Look at everything that it has imported from all the imports that we did. Now expand your simple stablecoin contract amount, like go to mint function here and just say 100 tokens. Okay. Transact. Oops. Oh, you've done some mistakes here. Insufficient allowance. Let me check. So, get required collateral for mint. Okay, so if I want 100 tokens, you just call it. Oh, we need these many. Okay, so maybe if I say get collateral for redeeming. Okay, maybe I will try with a lesser amount. Yeah, see, that is why these utility functions. Let me check. I gave the value for what, 50 tokens, right? Sorry, I mean, I gave 1000 tokens approval, right? So let's check if we need 50 tokens, 50 SUSD. How much collateral would we need? Okay, great. Can we try? Can we try 50? Go to mint. Can we try 50? God. Okay. So now I know why this is creating issue is because in the code we have messed up a little bit, just a little bit. So if you go to the mint function, because the mint function is what was, creating issue for us. So if you see 10 to the power collateral decimal, this has to be 10 to the power of price feed decimals. Otherwise, it would always be a zero less than. So if instead of, changing the value to 5, if I added one more zero, it would have probably worked. But that is an error. Now I have to just look into, because I tried it too many times and now it's stuck. So if I say total supply, will it work? Or will I have to redeploy? Yeah, let's just reload the entire page and start. Like, I'll quickly show you, right? We were just left with this is the forward space. Okay, token.a.c. We compile. We change it to mainnet fork quickly. Come on, yes. And we deploy. Come on, quick. Okay, great. Now we come here again and we open this. We compile, come here, it's at this. And what we have to do is we have to take the address of this as collateral token. Initial owner is just going to be this owner, right? And there was a ETH USD price address. Oops. Copy to clipboard, transact. Now this will go through very quickly. You can just like skip some of it, like right now, the ones that I've already shown, and we will quickly go to the mint function. Don't worry. Till then, let's play around. Yeah. Okay, this is deployed. So we'll copy this, and here in the approve, we will add this address, and then you have to approve like 1,000 tokens, maybe. So you have to add it with like 18 zeros. So let me just copy it from the screen, paste it here as the value. And maybe I would just increase it. Okay. Transact. So we're doing 2,000 tokens. Now we did a transaction. Great. And now we come to simple stable coin. Everything right now is like It's taking a little bit, yeah. Name, owner, all of this, symbol, total supply is right now 0 because we've not minted anything, blah, blah, blah. Now I'll come to mint. And by the way, you can get the like collateral for redeem. And here was get required collateral for mint. So if I put 100 tokens, right, like I want 100 SUSD. So what is the collateral required? This is the collateral required, and we've done more than that. Yeah, probably it should work. So I say, hey, I want to mint 100 SUSD, and I transact. Come on. It's good. Quickly. Yup. Went through. No errors. Now, if you check total supply, it's 100. Right? So if I want to also get collateral for redeem, maybe I want to redeem 50 tokens, I call this and I get, oh, this is what should be there. The balance is 0 ETH here. Total supply is this. And if I check the balance of this account, has it like changed? Yeah, it is changed, right? Because it deducted something. Now I want to redeem like 50 number of stable coins that I wish to redeem is like 50, right? So now transact. Let's see if we go through. Okay. Now the value is less. Why? Because this is the balance and this is what we have to what is required, minimum amount to perform a transfer. So we will need to approve more tokens to go through. And then again, these functions you can ignore because a transfer from, all of that is like inherited from ERC20. If you check the collateralization ratio, it's 150. Right now, if I want to make it like 100, transact, collateralization ratio 100, collateralized decimal. So yeah, balance off. So you can just play around all of this. Only the new functions. There's no need of looking into the older functions and all of that. And yeah, that's pretty much it. Very cute little contract on stable coins. And now you need know like how to write your own and mint your own stable coins, how to put conditions. And sadly, but also happy, I will see you on day 30. Till then, keep building. Just one more day that you have to push yourself through. And then you will take the well-deserved break. And so will me and Setu. Bye, guys.